All right, so this is for Mallory and Aubrey. And this is section 6.2. I said I liked chapter 6, and I still love chapter 6. I don't like section 6.1 because it's graphing, but we're done with that, right? Like, that's over and done with. And now we get to do the fun stuff, which is all the algebra stuff, and all this stuff, like, fits together. So I really like this stuff. We go from, there's 10 sections in this chapter. I think I said this in my last video, 10 sections, but we skipped section 3 and section 5. So tomorrow we'll be doing 6.4 already. Then we'll be doing 6.6. Okay, and then we'll be doing like a review section. Then we'll mid-chapter quiz like on Thursday or Friday. I don't remember. Friday probably. Mid-chapter quiz on Friday. So that's kind of the rundown of like what this week looks like. If you are missing assignments, parent-teacher conferences is next Thursday.
Wait, so we
Make sure you get them done before then. We don't have school Thursday or Friday of next week, so it's a 3-day week next week. Yay! Next week is a 3-day week.
That's gonna be so nice.
So anyway. All right, so 6.2, here we go. Exponential functions, the word exponential, okay? Or exponential equations. We're going to talk about these guys, okay? So exponential functions. A lot of people think, or they'll see things like 3x squared, and they'll say that's an exponent. It has an exponent, but this is technically a polynomial function, right? This is a square. This is a quadratic at 3x squared. An exponential would actually be like 3 to the x power. That is exponential. Do you see the difference between the two? Exponential. I can't spell. Exponential. So do you see the difference between the two? Exponents have to have the variable in the exponent. Here's where the x lives. Otherwise, it's just a polynomial function. I get that there's a second power there, but this is just a polynomial. Okay. So we're moving from this to the exponential functions, and that's what we're doing now. Okay. Exponential equations is going to have an equal sign, right? Where we're solving stuff. So let's say like that 3 to the x power. Let's say he's equal to 9, and what we're trying to do is we're trying to solve for x, okay? And we can do that pretty easily in our head. What 3 to what power will give you 9? To the second power, right? 3 squared is 9, so x equals 2. Like, that's easy. That's not too bad to solve for, right? Okay, so this is kind of what we're going to be doing. Got it? Okay, so let's go down and see what some of this stuff looks like. Let's go down here. And let's start with A. And this strategy, example 1, is going to be, it's called the change of base. So what we're going to try to do for these problems is trying to change the base, okay? So let's identify what the base is on each side, all right? Here, this has a base of 2, yeah? This one has a base of 8. Okay, those are like the big numbers. Those are the base numbers. What I want to do is I want to try to get those to be the same number, okay? And you can't do this by like, I can't multiply this side by 4 because if I multiply one side by 4, I have to multiply the other side by 4, and then that doesn't help me, right? I can't add in anything, but what I want to do is I want to change the base by rewriting like one of the sides, okay? So I'm going to change the base by rewriting, okay? So I have 2 here and I have 8 here. And what I can do, this is like the magical step. Ready? 8, did you know, is the same thing as 2 to the third power. Right? 2 times 2 times 2 is 8. So 8 can be written as 2 to the third power. Now, there is already a 3 on the outside there. So we're just going to take 8. Do you see what I did? I took 8, and now I'm going to replace 8 with 2 to the third power. And then I'm just going to leave that 3 that's on the outside of the 8, right? Like, so I'm just rewriting 8 as 2 to the third power. On the left side, this stays 2 to the x power, right? So it's like this was 8 before, and now it's 2 to the third power. Got it? Okay, now, 2 to the x power, he's just chilling. There's nothing he can do. But what is 2 to the third to the third?
2 to the 9.
Is it 2 to the 6th, or is it 2 to the 9th? Does this become 6 or 9?
3 times 3 when it's parentheses.
Yeah, when it's parentheses, you multiply. So that's 2 to the 9th power. And then, you know what happens? When I have these two as the same number, I can just cross them off, and x equals 9.
But couldn't
You could, but eventually we'll get to the point where we have stuff like this, and then you can't.
Okay.
So this was just baby stepping you, getting ready for that, yeah. Like Ava Leesley, like, couldn't I just multiply the 8 to the third through and then figure out what, like, to the second power? Yeah, right, like, I get it. Okay, So that's the strategy that we're trying to do here. Got it? Okay, B. My bases are 9 and 3. And we've got some really ugly exponents. Don't worry about those yet, okay? I want to change 9 and 3 to be the same number. Did you know that 9 is the same thing as 3 squared? Right? Yes? But then I have 2x minus 1 on the outside of that, okay? The right side, I'm just going to leave as the 3 because he's already 3 to some power, right? So I'm going to leave that as 3 and I'm going to leave that as 3. Got it? 9, like this was 9 before. Now I'm switching him and he's going to be rewritten as 3 squared. Got it? Okay, now I'm going to take this 2 and I'm going to distribute it through. So this is really 3 to the 4x minus 2. Does that make sense? If you distribute that 2 through, this stays 3 to the 6x. He's just chilling out, yeah? Okay, now what can I do? Cross off the 3's, and then I just solve. So 4x minus 2 is equal to 6x. All right. Are we doing good so far? No questions up to this point? We're doing okay? All right. What do I do now?
Subtract 4x.
Yeah, let's get the 4x and the 6x together. So minus 4x, got it? Negative 2 is equal to 2x, okay? And then let's divide by 2. What's negative 2 divided by 2?
Negative 1.
Negative 1, you betcha. So x equals negative 1. Okay, so that was maybe a little bit harder to solve for. Maybe not, I don't know. Was it okay? Yeah. Okay, sure. All right, now I'm going to add in here an example C, and I'm going to also do an example D. Can I do that? Because I know that you're going to have problems on your homework that are going to be just a touch harder, okay? So let's say that this is 8 to the x power equals 4 to the second power. Let's say that we have that going on, okay? So this is example C. Just put it off to the side, right next to B, okay? Because I know we're going to have a problem like this, right? You're going to have a problem like this. 8 to the x power and 4 to the second power. Got it? My bases are 8 and 4. And I want to switch those to be the same number. But here's the problem. A lot of you guys are going to be tempted to say like 4 squared. 4 squared is not 8, correct? 4 squared is 16, so that doesn't work. We've got to do something else. Jack said switch the 8 to become 2 to the third power, right? That's what 8 is. And then I've still got the x there chilling, right? And 4 is the same thing as 2 to the second power. So in this problem, I had to change both of the sides, right? Yeah? Okay, sometimes that might happen, right? If 8 and 4 are not the same thing, you can change both of the sides so that they become 2's, right? Okay, then what do we do?
2 to the 3x.
This will be 2 to the 3x. I'm just going to combine those. And then 2 squared is going to be 2 to the fourth power because I multiply these together. Okay, then the 2's cancel, right? So I have 3x equals 4, and then divide the 3 over. Ooh, I made a mess. Here we go. Divide the 3, and 4 doesn't divide 3 nicely, so we'll just say 4 over 3 and call it a day. Good? Does that make sense? So sometimes you have to change each side, all right, and not just one side. Got it? Okay, now I'm going to do one more really, really, really tricky thing to you because they're going to do this on your homework. I'm sure of it. Let's say I have 1/2 to the x power equals, I don't know, let's say 4 to the third power. I don't know. Let's do that. Okay. That's part D. I'm making this one up, so write this off to the side because I know they're going to do this on your homework. Okay. My two bases are 1/2 and 4. Okay. I'm going to start with a 4. And 4 broken down can be written as 2 squared, right? Like if I break him down, and then I still have the 3 power there, right? So 4 I've replaced with 2 squared, yeah? Okay. Now 1/2 can be written as a base of 2 also. 2 to the negative first power, right? Do you remember negative exponents make him into a fraction? Or like flip him, right? So like 2 over 1, if I have him to the negative first power, is the same thing as 1 over 2 to the positive first power. Does that make sense? Like the negative exponents flip them around, okay? So 2 to the negative 1 power is the same thing as 1/2. Remember that because you're going to have to do that in your homework, right? It might be like 1/3 power or something. Anyway, but then I have this x up here, right? So don't forget about the x that's already there, okay? Then I have my bases that are 2. So if I combine this is 2 to the negative x equals 2 to the how much? 6th power. Does that make sense? If you have a 1/2, you're just going to make it -1 or whatever exponent. Okay? Then what? The 2's cancel. So I have -x equals 6. And then I'm going to divide by -1. X equals -6. Okay? Now, if you ever want to check your answer, like why not plug -6 back in here and take 1/2 to the -6 power? See if that ends up being the same as 4 to the 3rd power. That's a good way to check your answer. So you could do that as well, right? But if they have fractions, that just means your exponent's going to be negative. Make sense? Okay, that changes them into a fraction. Got it? Good, good? Okay. Questions about any of that stuff? Okay, let's do some story problem-y things, all right? Okay, all right. Kristen starts an experiment with 7,500 bacteria. This is the start. And after 4 hours, that's my time, there are 23,000 cells. That is like a lot. This is my after amount. Okay, so starting amount, I have the time, and I have the after amount. Those bacteria are growing super fast. 4 hours to turn 7,000 into 23,000. That is crazy. Okay, write an exponential function that could be used to model the number of bacteria x hours, okay? I don't like the variables that they use because I'm not used to using those variables. So y, we usually call a. That's the after amount. So if you want to change your variables, change that to a. Okay? Do you remember what we usually call a, like in this problem? Like little a. That's the starting amount, which we usually call, you remember? We did this like one problem last week. We call it P. You remember what P stands for? Other than the starting amount? P is the principal. Principal? Yeah, maybe? No? Okay, P is the principal. B is like the rate, and X is time. So really we have A equals P R T. Something like that, right? P times R to the T power. That's what we have going on there. All right, we're going to plop some of our numbers in. Okay, so what goes in for A? According to the information they give me. What? 23,000. So we're going to put 23,000 here. 1, 2, 3 equals. Okay, P is, that's 7,500 number. Do we know what R is? I don't think so. Do we know what T is? T is 4. Okay, we're going to use this equation and we're going to solve for R. What the heck? Now, they tried to trick you just a little bit because this is technically not a exponential function. This is technically a polynomial, right? Because like R to the 4th power is not, like the exponent isn't up here, right? This is not an exponential function technically, okay? We're going to solve for R. How do you solve for R? Like, what can we do?
Take like the
Not, almost. We got to do one thing first. He says take the 4th root. Not yet. We will. Divide by 7,500. Okay, we got to get him gone first. Divide by 7,500. Okay, then we can do the thing, right? 23,000 divided by 7,500 is something like 3.06 with the 6 repeating, I think, is what you will get in your calculator. I think. Yeah? Yeah. Okay. Equals R to the 4th power. Okay, now, Gordon says, to undo a 4th power, you do the 4th root. Do you guys know how to do the 4th root in your calculator? There's a button that says like it looks like this. It might have a Y in the center of it. Okay, it's like a shift key. Probably a shift key that you use. Okay,
yeah.
So you might have to type in 4 and then hit this button. Okay, and then do that 3.0. Let's go 3.0667, something like that.
How would I do that if, like,
1.32? Yeah. 1.32, that's the right answer. R equals 1.32. That's what you should get, okay? So if you want to practice doing that, there's that 4 and then that button. Okay,
so I would
your
push-
button is this one right here.
Yeah.
So 4, and then it would be that, and then it would be the 3.06667, we'll say. Equals, there you go. 1.32, did you get that for R? Anybody have any questions about typing that in? Yes, yes.
It would be this one right here.
Bro.
So where's your shift
Bro.
key?
Very mobile here. Some
I don't think she's a button. There you go. Then type in.
Oh yeah.
Here's your user level 3.0.
if you hit 4,
Whoa, yeah.
So it's that one from shift.
Anybody else have a question on how to type it in?
What you said is right.
Got it? Anybody else want to know? Okay, R is 1.32. Now, they want us to write an exponential function. So I'm going to change this and let's leave A as A, right? We want this equation set up ready to go so that I can plug in anything for T. Okay, so my starting amount is still 7,500, but now I know what R is. It's 1.32 to the T power. This is what they want because in part B, they say, how much does it have after 12 hours? I can just plug 12 in here and get the after amount. Does that make sense? Okay. So we solve for R, we got R, and now we can use that to find A for any period of time. Okay. If we plug 12 in there, it's like 209 something. 209,869. So we started with 7,000. And in 12 hours, that's half of a day, folks. 12 hours, it turned into 209,000 bacteria. Almost 210,000 bacteria. 7,000. Holy crap, that's a lot. Okay? That's a lot of bacteria multiplying. Okay? Good, good? All right, they ask another question, and this is for compounding interest. Okay? Here's the formula that we use for compounding interest. My trig kids are actually doing this right now, but they're like solving for the exponent, and it's a little bit more complicated. But they're using this compound interest formula. A, write this in here, is the after amount. We've talked about that. P is the starting amount. Okay. We talked about what R is. That is your rate, so your interest rate, or how fast it's multiplying. T stands for time, but then we have another variable in there that's called N that we're not used to seeing. Okay, and N, they a lot of times will do compound interest. If you have money in the bank, or money in a savings account, I should say, in the bank. Do you guys all have savings accounts? Anybody? Savings account, okay? So your money is compounding exactly using this formula, okay? And N is the number of times that it compounds per year. Per year, okay? So that means if it's compounding, let's say yearly, versus monthly, versus daily, versus weekly. Sometimes they'll do weekly. Okay, versus quarterly. These are all different ways that you can compound. If you're compounding yearly, how many times are you compounding per year? What? 1. N is 1. If you're compounding monthly, how many times are you compounding per year? 12. If you're compounding daily, how many times are you compounding per year? 365. Technically, there's 365 and a quarter days in a year, but they always use 365 no matter what, even if it's a leap year. They don't use 366 on that leap year day or leap year. They just leave it at 365. Weekly, 52. Technically, it's 52 and 1/7 or something like that, but they just use 52. Quarterly. How many quarters are there in a year? 4. Okay, quarterly would mean like every 3 months, okay? So that's how that works, okay? So the number of times it's compounding, we get more in depth into that when you guys have trig class, but anyway, we'll talk more about that later. But that's all you need to know for now, okay? All right, let's dissect this problem. Compound interest. All right, an investment pays 4.2%. Stop. That tells me R, but R is not 4.2. R is the rate. But what number do I use? I didn't use 4.2. Move the decimal. 0.042. You've got to make it a decimal instead of a percent. Do we not convert between decimals, percents? Yeah? Okay. So 0.042 is the rate, and it is compounded monthly. What does that tell you? 12. N equals 12. Okay. If 2,500 is invested, what's 2,500? That's the starting amount, which is P. Is invested in this account, what will the balance be? after 15 years. 15 is T, so what are we solving for? A, that's what we don't know. A is the balance after 15 years. Okay, so we're just going to plop these numbers in. We don't know A. We know that P, I'm just using this formula right here and plopping numbers in. We know that P is 2,500. 1 plus 0.042 divided by 12. And then that is to the N, which is 12, times T, which is 15. Okay? Now, some of you guys think this is like really intimidating, plugging it all in at one shot, and I do too. I don't like plugging that all in at one shot. Somebody give me what 0.042 divided by 12 is. Like 0.0035. Check that and make sure. 0.042 divided by 12.
3.5.
3.5 times 10 to the negative third.
Yeah.
Is that true?
Yes.
So 0.0035. If I add that to 1, that would be 1.0035. Right? So if I combine those two. And then 12 times 15 is like 180, I think. So you can do this in bits and pieces. Now, does this look a little bit easier to type into your calculator all at one shot? Probably. It's going to end up being like $4,600 or something like that. 4,600 and something. Give me that number. $88 point, how much? 8.87. Okay, we'll round to the nearest like penny. That would be to the nearest penny. So 46.88. Okay, that is $2,500 changing into 46.88. Somebody said last period, that's not a whole lot of change. And my response to that is, I don't know if you guys check to see how much your interest is changing like every amount, but if you have money in a savings account, this was 4.2% interest after 15 years, which seems like a long time. Like you guys are 15. That's like your entire life, right? That you've had this money in there. And $2,500 has changed into 46.88. In an actual savings account, you will get like less than 1% in a savings account. You will never get 4% interest in a savings account, 4.2%. You will be lucky to put in $25,000 when you're born and 15 years later maybe end up with $2,600 just because the savings account is less than 1% interest. Like that's the way savings account works, right? You're earning money, your money is growing, but not very fast. Like it's really like a really low percentage. That's why people invest in the stock market and like do bonds and stocks and invest in whole life insurance and those type of things because that earns money a lot quicker. Or they'll buy like whatever cryptocurrency or whatever, like they'll do that stuff, okay? Because it does not. What's the percentage on a savings account right now?
Percentage?
Yeah.
Like a CD is like over 40.
If you get a CD, that's different. But like, what's like a savings account percentage?
1%.
What?
Maybe 1%.
1%. I said less than 1% because yeah, usually usually it's like really low. I said they'd be hard pressed. Like 4.2% annual interest. You're never going to get that in a savings account. So we probably are talking about like a CD or a bond or something here or something like that. So anyway, that's just how life works. It sucks. Like interest rates are ugh. Okay, all right, last question. Go to the backside. We're talking about inequalities here, and we're doing exponential functions. Okay, this less than symbol is not going to really change our process at all. We have two bases. This one is 16, and this one is 8. We want to try to make them the same number if we're solving for this, right? Okay, now, here's what a lot of people try to do. 8 squared. Is 16 8 squared?
No.
No. Okay, all right, so let's change 16 to be 4 squared, because that's true, right? 4 squared is 16. Is 8 the same thing as 4 squared? No. So what do we have to do?
2.
We have to change it both to 2's, right? Okay. So 16 as a power of 2. 16 is 2 to what power?
Third. What? No way.
How many times do you take 2 times itself to get 16? 4. Say 4. 2 to the 4th power is 16. And then we have the 2x minus 3, right? Is less than 8 can be written as 2 to the 3rd power. So we're going to rewrite them like that. Okay? Got that? Chilling out? He's over on the right side just chilling? Okay, so 16 was written as 2 to the 4th power, 8 is written as 2 to the 3rd power. You have to find the same number and make sure it works for both sides, okay? All right, this guy, this is 2 to the, if I distribute the 4 through, like 8x minus 12 is less than, what happens if I have nothing up here to like multiply by?
You just don't.
He's just 2 cubed. He's just 2 to the 3rd power, just like that.
I taught.
He's so smart. He taught me this class. He was that's how old he is. Ha! That's how old he is. Not me, I'm not old. That's how old Mr. Hubble is. He taught me when I was sitting right where you are. He was my teacher.
Or maybe.
Isn't that crazy? Okay, now what do we do? Bases cancel. They're both the same, so they cancel. So 8x minus 12 is less than 3. And then what?
Yeah, right, Jordan? Don't trust her. Just don't take it for granted. She's right.
Add the 12.
Divide by 8.
Yep. Now that's not going to come out nicely. 8x is less than 15. If you divide by 8 is like 1.875 or something like that, right? 1 7/8, okay? If you wanted to, you could plug, and what I would do if this was a test or something, I would take 1.875 and plug it back in for x and see if this comes out to be 8, right? That's a way of checking your answer. You don't have to do that, but I'm just saying, if you want to check to make sure you're right, you could do that, and that would work, right? So x has to be less than 1.875. You just solve it the way that you do before. The only time we flip the sign is multiplying or dividing by a negative. That's like standard. That's, the way that we always do it. Okay? Got it? Good? On your homework assignment, skills practice, the one that says skills practice at the top, do 1 through 6. You can skip the 7, 8, 9 at the bottom. And I don't know, for some reason my printing got weird. So 6-2 practice, like got printed at the bottom and then it doesn't have a heading on the next page. You see how that works? Like, anyway, whatever. Do the odds. So 1, 3, 5, 7. The story problem's not that hard. Okay? Read through it and see what you get. Okay? All right, there you go. Okay? Get a start. Number 1. Oh my goodness. Take a look at what they started you with on number 1.
How did that get under
Take a look at what they started you with on number 1. They're already 25s. Right? They're both the same already. So they made it really easy for you starting. Okay? All right. Goodbye, Mallory and Aubrey.
4.